Hi, welcome to the January 27th meeting of the Kubernetes IoT Edge Working Group. This is the meeting on the North America time cycle. Today's meeting has two items currently on the agenda. We're going to start with an introduction to Acry, which is an open source project that attempts to define a Kubernetes approach to representing IoT devices and engages in discovery of them. And then we'll follow that up with a discussion of the Eclipse ioFog project, specifically some recent or proposed enhancements to the Kubernetes integration that uses CRDs to control apps running at edge. So we have a rather full agenda, so I'm tempted to have the newcomers introduce themselves, but I'm afraid that these two things might take up the whole time. So how about if we reserve introductions and meet and greet till the end if we have time. And I'll turn this over right now to Jiri. Just a minute while I give you host ability. Okay, Jiri, if you like, you should be able to share your screen now if you have a presentation. Okay, we can see it.
Great, thank you. Thanks, everybody. Super excited to be here with you and share what we have been working on with Akri. I'm here with Kate. We're both software engineers for Microsoft. And we have been working on Acry for a while. So Acry is an open source project for building connected edge with Kubernetes, and it can be used to expose heterogeneous sensors, MCU class devices, and also like connected peripherals or brownfield devices as resources to the Kubernetes. So why did we choose to go to build Acry? When we looked at Kubernetes on the edge, we know that it can run just fine on a heavy edge. It can run on light edge. There have been projects like K3s or KubeEdge that runs just fine on light edge. But when you look at the tiny edge, and the devices that many of them are single-purpose devices, they cannot run a generic compute. We were not really sure like how Kubernetes fits in there. And so instead of running Kubernetes on these devices then make sense to expose them to Kubernetes. And so then the question was, is there a standard way for an edge cluster to find, monitor, and use these tiny edge devices? And because there is so many protocols that these devices communicate over and advertise themselves over, we didn't find an answer to this question. And so that's where we decided to go and build Acry. So Acry stands for Edge in Greek, and it is also an acronym saying a Kubernetes resource interface. And that's what it kind of tries to do. So the goals, we have a few goals. We wanted to simplify how you can expose these connected tiny edge devices to Kubernetes, but we wanted to do them in as Kubernetes native way as possible. And I'll go into the details how we are doing it on the next few slides. Then later, when these devices are exposed in the cluster, we also wanted the cluster to kind of automatically take advantage of them, and so allow you to automatically schedule workloads based on when the devices are available and deschedule them when they go away. Now, in order to make this useful for everybody, we understand there is so many protocols and there's probably nobody who can handle all of them. And so we wanted to make it super easy to extend it. So anybody can come and bring, either their own protocol discovery or bring down what we call brokers, which is basically the pod that interacts directly with the discovered device. And I'll go into the details. But the idea here is it's easy to extend. You don't have to kind of do that same boilerplate logic every single time you bring a new protocol. And finally, I think in order to have this useful for everybody in the true Kubernetes community way, we didn't want to hoard access to ourselves. We do want to share this with everybody. So it's an open source project released under AS Labs, so side by side with projects like Helm. And we are already working with community, kind of prioritizing and working together on extending it. And I'll talk a bit about our progress at the end. So with that, let's talk a little bit about what Acry is. Before I actually go into the details, I kind of wanted to do a few more kind of parallels that we are trying to draw to really design the Kubernetes native. Acry is designed as Kubernetes native application, composed of controllers and CRDs, but we wanted to go even further to really feel native in Kubernetes. And when we looked at Kubernetes, we know there are all these interfaces, CNI, CSI, CRI, making Kubernetes super flexible, right? You can kind of bring your own thing, and now Kubernetes can do more than it did before. Yet at the same time, the application developer doesn't have to worry about it. Then they get a common interface. And so we thought that, allowing Kubernetes to react to changes in the physical environment around the Kubernetes cluster should also be exposed through some interface like that. So that's one part. The other part, where we are kind of thinking a plug and play model, if you will, is in cloud, Kubernetes can dynamically change, right? You can scale workloads based on the traffic coming to the cluster. You can do auto scaling, you can do all sorts of policy driven. But it makes sense to kind of employ a similar concept for the edge, that when you plug in a new device, you don't have to have an admin to go reconfigure your workload so that it can take advantage of the device. So the second part of that Acry is reacting to the changes. So automatically deploy a workload based on the available devices. And they go away, workloads can be scaled down again. So now, how does Acry actually accomplish this? So Acry has 4 main components. It starts with configuration. So it's a CRD, and in the configuration, you specify what are the set of devices that you want to expose into the cluster. Here we have a snippet, just a very simplified one and kind of generalized. But in the spec, you basically specify what protocol you want to use. And this is used to then run the right code to discover devices over that specific protocol. And you can specify also, you can specify some filters. So you can say, oh, I want only cameras from this specific manufacturer, or I want to look for devices with this specific product ID. These are protocol specific. You can specify this configuration. And then optionally, you can also specify what we call broker pod spec, but it's really just regular pod, which is then deployed when those devices are discovered on either on the cluster or next to the cluster. So it's a configuration. This configuration is done by the Acry agent. Acry agent is a wraparound device plugin. So again, very Kubernetes native. Unlike device plugin, it handles network-based devices. So if you have network-based devices and they can be visible through multiple nodes, it deduplicates them. It also handles intermittent connectivity and additional features. So that again, application developer, even the application developer who is creating these discovery handlers, which I'm going to talk about, doesn't have to do this boilerplate logic over and over again. So Acry agent downloads the configuration and it uses that to determine what are the devices to look for and expose into the cluster. When an Acry agent finds a device, it registers them through device plugin so that scheduler can take advantage of it and schedule the pods. And it also registers them in this second CRD that we have called instant CRD. And we use this to keep additional metadata about the device. This metadata is then later put into the broker. And that's basically the pod that gets deployed to take advantage of the device. So the broker is specified, it's just another pod image, container image. There's specific Acry to it. This can be really anything. You can do your application specific broker. You can do protocol translation brokers. You can do authentication to the devices. You can do firmware updates. It's basically bring your own thing, but it's easy to add. And then Acry agent, when the broker is deployed, plugs in that information about how to connect to the device. Either it's an environment variable with a connection string, or if it's a local device, we directly mount it into the container. Now, how does this broker get created? So that's where the last component comes in play. So after Acry agent discovers the device and registers it in the instance, the control is monitoring the instances, and whenever there is a new instance, it will look at its associated configuration, and if the broker pod spec has been specified, we'll go and deploy the broker pod. And that kind of completes the circle. So one more piece of information. I mentioned there is the brokers, which are generic pods. I also mentioned discovery handlers. So these are protocol specific, and these are used to discover the actual devices on the network. It can be also on the nodes themselves. We currently support 3 protocols. So we support UDEF for local devices. So you can specify a generic Linux-based UDEF rule, and it will discover the devices on the nodes where the agent runs. We support OnWIF to discover IP-based cameras, and we support OPC-UA for industrial settings. And the code to do the discovery is running within Acry agent. We do have an extension that we are working on right now so that we allow to have these discovery handlers to run as separate pods as well. So with that, let's go through the flow. I kind of already talked about it a little bit, but let's do a specific flow of how you could employ Acry. So here we have a simple cluster, 2-node cluster. There should not be anything out of ordinary on this cluster at the moment. So let's deploy Acry. It's just a single Helm chart. All these components we talked about. I might not have stressed about it, but Acry agent runs on every node. And that because it's leveraging the device plugin, so it is running like a device plugin. We also want to run it on every node so that we can detect all the devices that each individual node sees. It could be that not all the nodes see all devices, and hence it needs to run everywhere. And then when the devices are discovered, it also annotates inside the instance CRD which nodes can see any specific device. And I'll get to that in a bit, why it's important. So after we have Acry, we can deploy our application. So this is an application that wants to actually take advantage of the connected discovered devices. Here, for simplicity, it's a single pod, but conceptually it can be anything, whatever you want. And this application has nothing to do with Acry. And if you didn't have Acry, you would probably go and provision it with some configuration which says, oh, this is the IP camera that you want to go look at. Or you would have to write your discovery logic directly into that application to go discover and connect the camera. But let's talk how it is with Acry, so you don't have to do those steps inside the application, keeping it really just a simple ML processing application in this case. So you start with the configuration. I mentioned that in the past. Here you specify you're doing OnWIF protocol discovery, and we are not specifying any filter, meaning any OnWIF camera will be exposed. And we specify the broker pod. So we want to deploy this specific container to every camera when we discover it. And we specify capacity of 1. And that means we deploy up to 1 broker per discovered camera. And I'll explain how that works in later. So now that we have configuration, the Acry agent, every Acry agent is basically listening for new configurations. And when there is a new configuration, it downloads it. And it uses that to initialize the search, right? So it invokes the right discovery handler, look for the set of devices as declared in the spec of the configuration. Then at any point, somebody else can come in and plug in camera. This might have happened before we installed Acry, but after. You can keep adding more cameras or removing them, and Acry will dynamically react to that. So if the camera is meeting the expectation, the filter specified in the configuration, the Acry agent will report it into the instance CRD and register them through device plugin. Then Acry controller notices it, and as we talked about earlier, it deploys this broker pod. It will deploy it into one of the nodes that can see the camera. In this case, both of them can see the camera, so it picked one. And because we had that capacity 1, it deploys a single broker. The controller also deploys several services. It deploys a configuration level service, which basically allows you to load balance across all devices that have been discovered given the specific configuration. So if you have 5 cameras, you will have one service which load balances across all 5 cameras. And it also deploys instance level services so that you can target a specific camera if you choose to. If you want to have a camera pointing to the front door, you can request that specific camera. This is also an extension over device plugin, which kind of generates a generic USB camera, but you cannot target a specific one. So now we have a service. Our application, all it needs to do is needs to be configured to take advantage of this Kubernetes service. So it's, again, very Kubernetes native. You don't have to worry about the discovery. You just leverage it as any other service in the Kubernetes cluster. And all is good. We're processing, the broker pod maybe is taking the RDSP stream, extracting individual frames, and then exposing them over gRPC, and this pod can take advantage and start processing them. So it's an example of application-specific logic for the broker / protocol translation. So all is great, but say the node dies. So what happens? Well, the pod doesn't have to be reconfigured because it's not pointing to a specific pod or a device, but it's connected to the service. But because the service doesn't have any pod behind it, cannot really do anything. Now, fortunately, because we keep the information what nodes were able to see the device, the controller detects that the pod and the nodes are gone and reschedules it to a separate node. And so now the ML pod can keep running, processing without any reconfiguration. Of course, there was a downtime. And so say you're running an industrial line and you cannot afford any downtime, whatever, until it got detected. And in this case, you could have deployed a configuration with capacity of 2, saying deploy up to 2 brokers per discovered device. In which case, Acry will schedule as many or up to 2 brokers if there are at least 2 nodes that can see the device. And if either one of them goes down, well, no downtime for the consumer application because the other broker will handle the connectivity. So now we have Kate have pre-recorded a demo for us, which actually shows Acry in action, so that all the talking there is actually some doing. It actually works. So let me play the demo. It should have audio, so please tell me if you cannot hear anything.
In this demo, we will showcase an Acry configuration that uses Acry to discover and interact with OnVIF cameras. First, we deployed a cluster. It contains a single node called Acry Demo running on an Intel NUC machine. And you can see from the instance type that we're running K3s. We went with Rancher K3s as our Kubernetes distro as it fits our edge scenario and is easy to deploy. Here you can see the Acry controller and agent. You can also see a demo streaming application that will be showcased later. Acry is configured by deploying a YAML file. Our Helm command did this for us. As we specified, we wanted to use the OnVIF configuration. The configuration is where you specify what leaf devices should be available to the cluster. You can see we have configured this cluster to have access to OnVIF cameras. In the Acry configuration, we have specified OnVIF as the protocol, with nothing in our exclude list, allowing any OnVIF camera to be seen by the cluster. We've specified a broker spec, which tells the Acry controllers which pods should be deployed to access any discovered cameras. We've specified a capacity of 1, meaning only one node can deploy a broker to each camera. For high availability, this number could be increased. We also specified service specs that provide stable access points to the cameras across the cluster. In this case, a service will be generated to access each camera found and one to access all the cameras. We can use existing common Kubernetes tooling, like Kubernetes dashboard, to see that initially there are no OnVIF camera instances found in our cluster. We can further confirm this by looking at our streaming application, which isn't displaying any frames. So to get this demo started, let's plug in a camera to the network. Acry will discover the camera, deploy its broker pod, and set up 2 services, one to access frames from all cameras and one to access frames specifically from this new camera. The streaming app is querying from both services. The larger top feed is pulling frames from all cameras in round-robin fashion, and each smaller feed is pulling frames from an individual camera. We will see this in more detail when we have more than one camera. With that in mind, let's plug in another camera. Again, Acry will discover the camera, deploy the broker pod, and configure the services. You can see this as our streaming app updates to reflect the new camera, both in the all cameras feed above and in the specific camera feed below. So you can imagine what will happen if we plug in a third camera. Sure enough, yet again, Acry will discover the camera and enable our streaming app to show us feed coming from all cameras and individual feeds from each camera. We can go back to our dashboard to see the discovered OnVIF cameras. And beyond that, we can drill down into the camera instance to see what nodes are accessing the camera and the metadata that has the connection information for that specific camera. This metadata is inserted into the broker pods as environment variables. This sample was built for OnVIF cameras, but keep in mind that Acry was designed to be extensible, allowing anyone to add their own capability definition and logic to deploy any custom broker. In this demo, we will show
that will be for our presentation. So a little kind of a summary on the functionality. And please also, if you have any questions, I can also stop and discuss. The summary of the functionality. So Acry works as a resource interface. So folks writing code that want to leverage devices don't have to understand the logic, how to go find and use them. This is abstracted away by Acry. It does not only device discovery, but it also handles intermittent connectivity and removal of the devices. It supports this broker-based deployment where when a device is discovered, automatically the workload is deployed to leverage the device. Supports high availability access because we can deploy multiple brokers in parallel, and deploys these services that allow to take advantage of the parallel brokers, but also target specific devices and load balance across all devices within a configuration. We have support for multiple protocols. I mentioned OnVIF for cameras, UDEF for local devices, OPCA for industrial setting. I'm also happy to announce that folks in the community already joined the efforts with us, and we have right now PR pending for ZeroConf and co-op protocols. So we are already extending this. It was designed to be extensible, so it's super easy to bring your own brokers because it's just a pod spec. And we are working into extending the protocols handlers so they can be their own separate pods as well. And then it simplifies multiple scenarios. I think I mentioned this already. The brokers can do really anything. They can be your application-specific logic. They can do protocol translation, data ingress, authentication to devices, firmware update. It's really up to you. Acry gives you that flexibility to react to devices that are covered on the network. A roadmap. So we understand that this is only as useful as the amount of protocols it supports, and so we're working on adding more protocols and further simplifying the extensibility. In the demo here, we have shown a deployment strategy, and specifically one where there is a broker deployed per discovered device. That's not necessarily super flexible. We already, because we are leveraging device plugin, you can kind of use those resources directly yourself. You can detect it. We add extended resources on the nodes, and so you can schedule yourself workloads however you want. But in order to take advantage of Acry, we want to allow that dynamic deployment. And so the additional deployment strategies we are thinking about are, for example, pooling. So you can deploy multiple devices to a single broker, or combining multiple different resource types together. So you can have a camera and a GPU under the same broker, so you can do the processing locally. And then improving composability. So we look at Acry rather as a framework. We want to see it more as a library. So we want to enable other projects to take advantage of reacting to the physical changes in the environment. So say, your application is some sort of an operator, right? It has its own CRD, and now it would like to generate its own custom objects based on the changes in the physical environment. Say if you have some ML application, it wants to schedule its own pods when there is a new camera. But because its pods are represented as the custom objects, well, now Acry could not be used. So we want to allow you to basically not just generate pods through the controller, but also generate other custom resources. So it's composable with other projects in the Kubernetes community. But ultimately, we think this is only as useful as the support and it gets with regards to the amount of protocols and people who use it. And so we are reaching out to the community to kind of gather feedback and prioritize based on the community needs. To the point, we have already released it on GitHub, all the source code. We have a Acry channel on the Kubernetes Slack to communicate with the community. We're just about to start our meetups so we can further engage. And ultimately, we want to see if if folks find it useful and want to use it. Then we think it makes sense to have this be part of a community governed foundation, so that there's no single company which is kind of saying what goes in and what goes out. And we would be very happy if you guys find it useful to go that route. And that's about it for the presentation. So be happy. I'm here, like I mentioned, I'm here with Kate, both developers on the project. So be happy to answer any questions or listen to any feedback that you might have.
Well, thanks, Jiri. That was a great presentation, and I look forward to checking this out myself. I know it's hard when you're presenting to be watching the chat, but there are some questions that came in on the chat. I can read them so they get picked up in the recording.
Okay.
There's a bunch from me and one from Barry. I don't want to monopolize it, so Barry, let's do yours first. What he said was, can multiple brokers or for protocols connect to the same device? In other words, can have a protocol stream data and I don't know, Barry, do you want to read the question yourself?
Yeah, well, suppose a device requires two different protocols, one to stream the data, but the other to do the remote updates. When I discover that device, can I connect two separate brokers to it simultaneously? Is that something you thought about?
Yeah. So the most obvious ways you would deploy two different configurations where you can target either two separate sets or the same sets of devices, and then you specify two separate brokers. And so then these are scheduled independently. It could be that one is firmware update, so it's kind of one-time job and it's done. The other one could be something which is ongoing and processing, or one is a data plane, there is control plane. They can come completely separately. Depends, of course, on the protocol and the device, if it allows simultaneous access. But from Acry perspective, yes, no problem.
So Acry,
the device instances are, sorry, go ahead.
Acry sees it as two devices in that case.
In this case, Acry would see it as two separate devices because the devices are scoped underneath the configuration. Perfect. If you want to have it as a single thing, then it's a single configuration.
Right.
So a few things I was thinking of. I'm wondering if this anticipates deploying whole Kubernetes clusters at edge locations versus a scenario where your Kubernetes control plane is, say, in a public cloud or in a regional center with, say, 100 connected Kubernetes worker nodes. When you go to that latter scenario, you often are going to have intermittent connections. Can Acry handle that scenario where the discovery perhaps works asynchronously while the control plane is down and then reconnects to have the right thing done when communication gets back to normal?
So yeah, so right now, Acry does take a dependency on having the tightly connected control plane, just because the instances are stored as part of the CRD. Having said that, I could see that, as long as you're okay waiting for the updates until it reconnects, then that logic could be added. But right now, we are expecting to have the control plane running on the edge as well.
Then the other thing I was wondering, I saw in the demo that Acry starts a broker pod to work with the device, but does it do any cataloging, building some kind of a queryable database that has an inventory of these that can be used generically over time so that maybe these pods have independent life cycles or something like that?
Yeah, so Acry does two things. It is using the native device plugin, so it basically registers these devices as extended resources on the individual nodes. So you have this list. That's obviously very simple because it's just one annotation. It also adds those instances in that CRD, at which point it's up to the protocol, the discovery handler, to put any metadata that it sees fit about that specific device. So the instance aggregates all the devices that are there. Now, if you want to do some additional, like, say you want to do some deep inspection of the device and really understand what it is, our view is that this is not part of the discovery handler. It's that individual brokers then do this extra logic. And so then, you could technically go and add your broker, which does further deeper inspection and captures more metadata. But you can easily create the discovery handler, which does all this and stores them in the instance CRD, or has its own thing where it wants to store it.
Okay, yeah, it occurred to me, if you saw the stream of my questions, I asked if it would not only catalog devices, but also data streams and event streams that might come out of this. But upon further contemplation, going by the principle of separation of concerns, it hit me that it's probably best not to build that in Acry. Even if you needed those things, build it on another layer that is triggered by the Acry device discovery. And it will be much easier to maintain and much more flexible to do it in that kind of architecture.
Yeah, that's been also our thinking, that like you keep the minimum logic in the discovery, and then anything specific goes into the broker. But if you want to bring your own discovery and handle it there, you can.
Okay, and then my final question is, do you have to enable privileged mode in order to get the Acry discovery to work?
So I think for the local devices, we are using the privileged one. Okay.
No, we removed it. So that was something that at first we thought device plugin documentation suggests using privileged mode, but we don't need to use it. And for instance, with UDEV, if your broker wants to use those devices, say a local USB camera, that pod would probably want to enable privileged mode or specify specific privileges on that device. But no, it's not enabled in the agent currently.
Oh, one final question I forgot, but does it do something to eliminate duplication of devices? I'm thinking a scenario of a multi-node cluster discovering network attached cameras, and really all of them would see that camera potentially. How do you prevent that from appearing multiple times?
Right. So this was one of the extensions on top of pure device plugin. So when a device is discovered, it's like I mentioned, it's scoped within the configuration. But then we also leverage the protocol discovery to basically find something unique about the device. So say a MAC address, and then we hash it into the identifier. So then they get deduplicated based on that. Inside the Acry instance, they are tracked a single camera, and we just keep a list of nodes that can see it, but they get deduplicated. And this you get kind of for free if you leverage Acry. You don't have to worry about that in your discovery handler.
Okay, I think we have time for one more question, but we have Serge on the agenda. Dion, I saw you had a few in chat. Do you want to ask a question?
Just one. I saw that you decided to use Rust for this development. I just wanted to, pick your brain on the decision why you thought it's a good fit, and what was your experiences with using Rust for these kind of projects?
Yeah. Thanks. So yeah, we kind of weighed options between Golang and Rust. There were multiple reasons why we decided in the end for Rust. So I'll go through them. So first, we saw the amount of work that the compiler is doing to ensure the high code quality. There is literally a lot less test code that we had to go write, because a lot of the edge cases are covered by the compiler to begin with. So code quality and developer speed was one. Second, because this is a kind of a standalone thing, right? Like it's just interacting across Kube client APIs. We didn't necessarily see the need to be directly tied with the Golang, because as long as we can, access the API server that was abstracted away. Also, Rust support generics. So there was this templated generated code, so that made life a little easier. And then final, I think what we looked at, it did produce smaller, it produced smaller binaries. So being on the edge, trying to be smaller, that was something we wanted to go for. And then finally, the interop with the C code. So the thinking is like, if you need to leverage some, devices, and you might want to use some C libraries, the interop with C code seemed more straightforward than with Golang, where you have to go create those annotations. So all these, it felt like Rust is a little better choice, even though it means that it is not something the community is as used to as the Golang.
And if you chose to write your own device discovery plugin, are you forced to use Rust because of this, or can it be in any language of your choice?
Great question. So in our current model, the discovery handlers are running in proc in the agents. So that means Rust. But we already have work pending to basically extend this so that you can run these as individual pods. At which point it's an interface very similar to device plugins, just a gRPC interface that you have to expose, and you can write it in any language. So again, like the extensibility, I think, is a key here, because we just cannot cover the wide spectrum. And so we want to allow you to bring any language and write it as separate pods.
So Barry, did that answer your question? If not, jump in.
No, that was exactly what I wanted to know. Yep.
Okay. Okay, thanks. We're going to have to switch over to give Serge time. So this was a great talk. Thanks again, Jiri, for covering the aspect of handling devices and apps that work with those devices at Edge. As a segue, the Eclipse ioFog is an interface that manages more the applications that might work at Edge as opposed to devices. So Serge, why don't you I've given you co-host permission, so why don't you take it from here? And if I didn't do justice to ioFog, go with an alternate explanation.
Sure, thank you. So you should be able to see.
We can see your screen, thanks.
Cool. Okay, thanks. So my name is Serge Radinovich. I work for Edgeworks and we maintain Eclipse ioFog. And so today I'm going to talk about ioFog's Kubernetes integration, mainly with the hope of just engaging the community and getting some feedback and maybe some discussion about architectural questions we have. So I'll sort of canvas where we are today, where we have been, and where we think we're going, and bring up some questions at the end. So before I talk about the integration of Kubernetes and ioFog, I'll talk about ioFog without Kubernetes for context. So ioFog is a standalone Edge native platform. So it does do a lot of things that Kubernetes does here on cloud, just for the Edge. So it does container orchestration, routing, device management, user management, those kinds of things. And I can drill into those through some ioFog concepts. So just as Kubernetes has its fundamental native types like deployments, famous head, secrets, config maps, etc., and even nodes at the platform layer, ioFog has its own. And so I've just separated these into two layers, platform and application. So platform being ioFog itself. We have three there. First, we got the controller, which is sort of the brains of the operation. It's the main component of your control plane, and I'll dig into the control plane soon. Controller exposes a REST API for users to manage ioFog through. And then you have your agents. So agents run on the Edge hosts. They are akin to a kubelet in that they start up and spin down, manage containers on the hosts. We have routers. Routers are implemented using Kubernetes dispatch routers, which are AMQP based. And so what routers let us do, which is really important for ioFog and Edge environments, is allow microservices running on Edge hosts to expose endpoints for external users through actually the control planes network rather than the Edge network. So in this diagram, you can see there's a firewall splitting up the Edge and the control plane, which is just a single control in this diagram. And we just have a single Edge network in this diagram, but it could be multiple Edge networks with firewalls in between. So we've got these Edge routers talking to an interior router that's maybe somewhere in the cloud. And they're able to just connect to that without requiring any inbound firewall rules from the interior router to the Edge router. And so on the application side of things, main workload concept for ioFog is a microservice, and we have an application type as well that groups them together. Public ports are a concept that represent that externally accessible endpoint of edge microservices I mentioned before. We have IO messages and routes. So routes are unidirectional communication channels for IO messages between microservices. And we provide SDKs for users to deploy microservices that use IO messages. We have edge resources, which are similar to sort of Acry devices. They specify a device, a protocol, and an interface to that device. And we have microservice catalogs as well. So how do you use ioFog without Kubernetes? We have a unified CLI. It's unified in the sense that it allows you to do both platform and application layer management. So in that sense, its functionality is sort of similar to Ansible and kube control combined, in the sense that it's able to push out to infrastructure to deploy the platform as you would with Ansible. But the user experience is entirely like kube control, and that you'd be writing YAML specifications to drive resource management of some of those resources I just mentioned before. So just below, I've got some examples of the most typical commands you might do. You might be deploying a control plane, some agents, you're setting up the ioFog platform, and then subsequently you can deploy applications, routes, and all that kind of thing. Right, so right now, our Kubernetes integration is at version 2. So I'll talk about where we are now, and then I'll talk about where we were before that, and then I'll talk about where we're going. So ioFog with Kubernetes, in that diagram, it looks very similar to the previous diagram, except of course now we've got a cluster and the control plane sitting on that cluster on some set of Kubernetes nodes. So what the control plane looks like on the cluster is basically a set of deployments and services and other resources. And what's different now is that we have the ioFog operator deployed on the control plane and a port manager. So these are new components that aren't relevant to the vanilla or non-Kubernetes ioFog deployment. So the ioFog operator has a control plane custom controller that looks out for control plane custom resources to set up your control plane namespace. So users can manage the control plane through that custom resource using kube control naturally. And the port manager is responsible for exposing public ports as load balancers or cluster IPs. So just a reminder, those public ports are externally accessible endpoints for endpoints on edge microservices. And so if the port manager is creating cluster IPs, then in that situation, you would have some ingress configured externally to enable that to be reached by the user over here. So this entire system is ioFog controllable. You can deploy it and subsequently manage it with ioFog control onto the cluster. It's also Helm installable. After you Helm install, you would connect to the control plane using ioFog control to continue managing it after the installation. So going back in time, the version 1 of the Kubernetes integration, what that looked like, I won't necessarily go into this sequence diagram, but I'll talk about it briefly. The version 1 integration leveraged virtual kubelet. So what that enabled was a more Kubernetes native integration in the sense that ioFog microservices were able to appear as pods, ioFog agents appeared as nodes. You could deploy the Kubernetes deployment kind effectively to the edge, and you could leverage Kubernetes schedulers. But we found this to be quite an awkward integration. As I said before, ioFog is a standalone platform with its own unique concepts, and they don't necessarily map perfectly to Kubernetes concepts. So this was often unnatural and confusing, and would ultimately sort of force ioFog to at least down the line, become more like Kubernetes. And that would sort of constrain us, particularly in edge use cases where we might not want to be constrained. So we decided it's preferable to enable Kubernetes to do ioFog stuff rather than make ioFog look like Kubernetes. So just briefly in the sequence diagram, on the left, you've got the virtual kubelet column. What that does is talk to the ioFog controller to determine what ioFog agents have been deployed on the edge compute network. And then subsequently, once those are registered, the Kubernetes scheduler is able to schedule pods onto those agents via the kubelet instances. So moving forward with our Kubernetes integration, what we want to improve on is just to mainly enable kube control to be a full substitute for ioFog control for both platform and application management. And naturally, this means we have to grow our catalog of custom resources and custom controllers in the operator. So right now, as I mentioned, we have control planes, but moving forward, we're going to need agents, routers, applications, microservices, routes, edge resources, and more. I have a link to an architecture document here, but I'll go over the links towards the end, particularly for the documents that we seeking feedback for. So just to be super obvious and drill into your brains what we're talking about, we would be enabling these use cases essentially through kube control to manage ioFog and the edge applications and microservices. So you'd be looking at applying control planes, agents, routers, and being able to get describe, edit, and so on, all those resources. And same with application level stuff. So some of the architectural questions I would like to raise and get feedback on. This is an interesting one. Should the Kubernetes capabilities of ioFog be a means to deploying ioFog agents? So what that means is, say you have these bare metal edge hosts, should the Kubernetes cluster essentially be running a job or similar to SSH into those hosts to install the ioFog agent stack? So this is sort of an unnatural design, at least in my eyes, because you have the situation where the cloud is pushing to the edge by SSH, and normally it's the other way around. We don't really enable that way. But it does allow users to deploy the entirety of ioFog using kube control, which, yeah, if we think the community really loves that idea, this concept is definitely technically feasible. So we could look at it. But yeah, alternatively, we could rely on a separate tool for provisioning those edge hosts with the ioFog agent stack, like ioFog control or Ansible and so on.
So are you asking for us to answer these questions now or discuss them right now?
I'll just rattle through all the questions. There are only a few, and then we can discuss afterwards. Yeah, thanks. So, yeah, and just in the diagram, just to be super obvious what's going on. At some point, say the user has created an agent custom resource. The operator picks that up and either directly itself SSHs into edge hosts to install the software, agent software, or creates a job to do the same thing. That's what that would look like. But obviously, you're going to need to allow the cloud to be going through into your edge network, which is probably not desirable. And typically, platform deployments go from a workstation within a network that's either given access directly to the edge network or is sitting in the edge network. Then another question we have is whether we should enable ioFog custom resources such as microservices to map to Kubernetes types like pods. So I kind of mentioned this was somewhat unnatural when I was talking about version 1 virtual kubelet stuff. The benefit of this would be to allow ioFog custom resources to be used both for cloud and edge workloads. So in this sequence diagram, I'll just go through it. It's pretty small. You've got kube control. User is creating a microservice custom resource. The operator picks up on that, determines in this situation, the microservice has both a cloud workload and an edge workload. So not only does it create a microservice against the ioFog controller API, but it also creates a pod with a Kubernetes API. So you end up with 2 containers running, one on the cloud, one on the edge. And then sort of related to this question is a bit of an extension is I would just like to think what people think about, would like to hear what people think about the virtual kubelet solution versus where we're going with the purely custom resource approach. Yeah, so we can go over the questions now if anyone has any other questions. Here are a bunch of the important links. I encourage everyone to join our Slack channel to partake into the discussion. That link should work for 30 days or so.
Can you drop a link to this deck in the agenda notes doc too, so that people can?
Yes. I will do
later. Thanks.
And then we have documents for review. And yeah, if you take a look at those and give us feedback on Slack, that would be great.
Same for you, Jiri. If you can drop a link to your deck, that'd be great. Okay, does anybody have any questions? I think particularly he's looking for responses from users. I know a few of us here are more like vendor perspective, but any thoughts on this?
Steve, this is Todd P. Thanks for setting this up. Yeah, just to kind of add to what Serge was saying, we're definitely looking for, user vendor community feedback on some of the kind of core questions, specifically about the one from kind of like, should the cloud plane reach out to the edge or vice versa? We've had input and requests for both, really. I think we have a thesis, but wanted to kind of, get the wider Kubernetes community input on,
how
in
the history of IT, that's always been a big,
feedback from your customer.
That's always been a big question of whether the central reaches out to the remote clients or vice versa. And one of the big issues in my experience as an engineer has been that if the cloud reaches out, you have to distribute credentials out to these edge locations to authenticate them. And the other way, they can kind of largely look the same and call in, and you've kind of pre-installed them with some means to establish the authenticity of who they called. But hey, that's an implementation detail. And go ahead.
Way from the edge up using some secure device onboarding mechanism, a rendezvous server, etc. We'll have to get some sharing on that.
Yeah, but yeah, if you can solve that problem of getting credentials out to thousands of edge locations, you've probably, as a startup, got a much bigger market just for that alone.
So LF Edge SDO is a project to solve that.
Okay.
So we'll get some experts in to share, and I'll put that on the agenda.
What did you call it? LF Edge SDO?
Yeah, secure device onboarding.
Okay. I mean, just to give a context more from actual applications and production is, we never are allowed to go from the cloud into the edge via SSH. And
that's correct.
We used SSH to do communication, but we had to set up reverse proxies on the edge and they have to call back in. And so that's been a big pain point for us. So the only way we're allowed to do it is to have the edge call out. Otherwise,
that's exactly right. All of our customers are edge out, and we assume there's a wall up every time. And we assume it's over satellite.
Yep. Yeah, we have all kinds of different connections, but they never, we can never go in. It just never happens.
Yep.
for us.
Yeah, and frankly, that is the kind of core architectural tenet of ioFog, and always has been, kind of edge in or edge out, whichever way you describe it. It's just an interesting architectural discussion with some users who are both Kubernetes users and ioFog users, who I think, are thinking, how do they build this, on-demand edge cloud for their users? But I think, the core tenets in ioFog are that you kind of lay down the infrastructure first, and then that becomes part of the global stuff you can use, rather than letting the central cloud go and, deploy into bare metal and stuff.
Mm-hmm.
I mean, it seems to some degree, even if you do the SSH model you have, you're still going to have to configure that host with an SSH server with credentials from the cloud. So you already had to do a bootstrap. So maybe it's better to do a bootstrap that doesn't require that inbound connection if you're going to already go through the trouble.
Yep.
Yeah.
There's a number of technologies. I'll make sure we get on the next agenda.
Okay, that sounds great. I'll put it in when I do. Do you want the North American cycle or the
whatever this is?
Okay. So it'll be 4 weeks from now.
Yeah.
Yeah, the other one you might have to wake up in the middle of the night, depending on what time zone.
That's fine. I'll do it if we need to, but I'll get one of our experts on it. So
okay, sounds great.
You also asked about being a Kubernetes model versus ioFog model, and could you talk about what you felt were the things that forced you to say no, we can't use the Kubernetes model, and we have to, because that's to me, that's one of the downsides, I think, is we deploy all our services using standard Kubernetes definitions, whether they're in the cloud or on the edge in K3S. But now we have to use a whole new definition to deploy the same services we might run on a device that's a little bit too small for Kubernetes, but it just runs Docker, and we would use ioFog for that. But now I have to use a whole different paradigm for defining it and deploying it. So I'd be curious to know why you thought, what was constraining you to go down that route? I mean, maybe virtual kubelet wasn't a way to do it, but just the standard CRDs and stuff are kind of nice.
Yeah, so the main difficulty was mapping the Kubernetes native types like deployments, datasets, and such to ioFog applications and microservices. It wasn't an impossible thing to do, but definitely drove our development towards a more Kubernetes sort of centric manner, which we didn't necessarily want to do. But yeah, if the community thinks the Kubernetes native way is the way to go, Kubernetes native or the highway, then it's something we can explore again. And
well, in a way, going CRDs for these apps that maybe aren't traditional Kubernetes containerized apps is still a Kubernetes way. It's just a different way. So in other words, they don't look like the same apps that you'd run on a conventional Kubernetes worker node, but maybe in a way for Edge, in my opinion anyway, that's a good thing, because the Kubernetes scheduler was built on this premise that you've got a huge inventory of resource that is pretty much homogeneous, and the scheduler is doing you a favor by randomly putting your workload on one of these out of a big pool. Yet at Edge, often what you want to run at a particular Edge location is unique to that location. And arguably you can be fighting the scheduler rather than having it do something useful to you. You can label the heck out of it and put all kinds of constraints that get it to exactly the location it needs to be. But at the end of the day, you have to ask yourself, did the scheduler actually work for me or against me? And if the answer is that going the route of virtual kubelet and making every Edge location look just like a pod ends up causing a bunch of extra work with no benefits, maybe that wasn't the best way to go. The other downside to making this look virtual kubelet is your scale out. I mean, Kubernetes in theory, I think the docs maybe say there's a limit of 5,000 nodes. That could be it's changed. I haven't kept up on it. I doubt if it's gone to 10,000 though, because if you look at the write-ups on what it takes to get to 5,000, there are some real heroic efforts and massive etcd clusters. And if you go that route of every Edge node is a virtual kubelet, I think you're up against that kind of stuff. Whereas with CRDs, with your own controller, not using necessarily the conventional Kubernetes infrastructure, I'm not sure you're up against those same kind of, it's not just the upper limit, but how much resource gets burned if it's non-linear as you approach the limit or even get to half the limit. That could be really undesirable in an edge scenario. And the other thing is that Kubernetes scheduler was built originally on the premise that it's pretty much reliably connectable to all these locations. And if you're doing a central control plane with bare nodes out at edge, or the things at edge aren't really even Kubernetes nodes, I believe the ioFog promo says they can be like iPhones that I assume are not Kubernetes nodes at all. They're just something capable of running a container runtime. You're trying to really manipulate something into something quite different from what it was originally architected for. And you're probably causing a lot of strain on a lot of those assumptions that went into the engineering. So I don't know, I'll get off my soapbox, but I think it isn't a gimme that making your edge nodes look exactly like conventional Kubernetes nodes is, it might be easier in some regards, but it isn't necessarily easier to use if you've got to fight the scheduling and connectivity concerns.
Well, you certainly convinced me, Steve. So that was a great argument. I mean, I think going to the CRDs is really a perfect, rather than having to use the ioFog commands and stuff, but just bring that into the controllers is perfectly acceptable, right? And especially given what, the arguments you just said. So that makes perfect sense to do that.
Yeah,
that's what I wanted to hear, is like, what was the real, what was causing headaches? And that's definitely sounds like that would be it.
And that's definitely where we've arrived at our kind of like V2 architecture go forward, right? I think as Serge said, it's like, rather than trying to force fit it, it's just to allow, Kubernetes and kube control and, to be able to orchestrate and make calls out to ioFog seamlessly without you changing your tooling or whatever. But kind of married the two worlds. I think, Steve, as you said, Kubernetes, talked about as, hey, great way to build a 5,000 node cluster in the cloud. I think we've kind of like, focused on how do you build 5,000 one node clusters at the edge, right? And, in ioFog, and trying to marry those two worlds together and make them a kind of like seamless transition from cloud to edge and back.
So with that model, how would, say, for example, a cloud service be able to access an edge service, right? It wouldn't see it as a Kubernetes service in that case. You'd have to like put that in the application layer of that cloud service to say, I have to go look up something and figure out what the VAN is, the router and the QPID, and flow it down to it. Is that?
Yeah, so I mentioned in that Kubernetes deployment of ioFog, the component called the port manager. So the port manager will basically talk to the ioFog controller to determine what public ports have been created for your edge microservices. And based on that list of public ports, it will set up either load balancer or cluster IP services on the cluster. So those edge microservice endpoints are accessible through your Kubernetes network via load balancers or some ingress.
Okay, so that's still transparent. You can still access the edge services. You don't know that it's running on ioFog edge.
Yeah, you're still accessing just a Kubernetes service. Yeah.
Nice.
Yeah, that's what Scupper and Kubernetes Dispatch Router allow us to do.
By the way, we are over time, but it seems like people are still really interested in discussing, so I'm not going to pull the plug on this, but apologies to anybody who does have to drop off, but let's just keep going if participants don't mind. I know I don't.
Yeah, well, I got most of my questions.
I know the other issue to be resolved, Todd, I think you threw out the idea of whether this is a central cloud-hosted control plane talking to some kind of managed edge nodes that may or may not be Kubernetes cluster nodes, or whether each of these edge nodes is like a mini tiny Kubernetes cluster in appearance, and what you're doing is federating a huge number of Kubernetes clusters. I'm not sure that there isn't maybe even a third option, but one of the things that I think needs to be considered here, if you're looking at this as an architecture where there's a central Kubernetes control plane and the edges are still using Kubernetes networking to get to these edge locations. Once again, it kind of assumed in a big data center model that that network connectivity was pretty much reliable enough to be doing synchronous operations. And the reality in these edge applications is often that it isn't, so that you might want to build this to enable using protocols like MQTT or others that are more tolerant of intermittent connectivity, bad bandwidth, and things like that. Could you maybe offer a little color on what ioFog brings to the table there? Because I saw that it does take on some of the connectivity issues.
Yeah, definitely. I think actually I'm going to flip that to Kilton because I know this is one of his favorite topics du jour of disconnected nodes at the edge.
Yep. Happy to talk about it. I was thinking maybe I should answer this one. The concept that we're trying to work with here is, do you need to check in with any certain frequency in order to be still an active, manageable device or node in the system? And if so, shouldn't that be flexible rather than saying that everyone's connected at the same level? So at the core in the ioFog control plane is this notion that each edge compute node should have a parameter that says, when do we expect it? And so if you're going to call back on your satellite backhaul 2 times per day, then you really want to give it about maybe a day or so before you say something seems to be wrong, because you could definitely miss one shot and say, well, it's probably still alive. Let's be sure. But if you're calling back every minute, then it's just a matter of 5 minutes or something before you would want to say there's something wrong there. So given that, and given that the edge nodes reach out to talk to the control plane, that's the whole punching out or dialing out thing, that's a good setup. But we have had numerous requests to allow someone to use their MQTT message infrastructure as the way to do all that communication, because they've already got those pathways. And as you mentioned, Steve, that protocol is really tolerant of disconnection. It's very lightweight, low overhead for the packets, right? So what we're thinking of doing is taking the core thing we've got, which was designed for this scenario, but allow you to change which protocol you carry it over. And that way you can basically choose what's my control plane network, as opposed to how do I set up the control plane network and what do I allow? It's like, oh, if you've got an MQTT system going already, then great, we'll just ride on top of that. And this also means that anything that gives you a managed pipeline, this is like discussions we've had about like the Hano project at Eclipse, you could use that to carry this traffic. And so places where you normally watch and monitor and say, what messages am I piping through? You'd be like, oh yeah, and those are the messages related to the ioFog edge nodes talking to their control plane. So the basics are already there, but how do we want to expand it? And so I think additional protocols is a way to then give you that flexibility.
Okay, thanks, Kilton. Anybody else got any remarks? Okay, well, thanks for that presentation, Serge. I'm gonna have to go take some think time on it, but it looks intriguing, and it's a nice combo of handling kind of app distribution along with the devices in the previous talk. I see some names here. I know we're way over limit, but if people are interested, I think there might be some first-time participants in the meeting. If you want to say hello and introduce yourself, or we can go all around if people want to do that. If not, I'll just stop the recording and we'll call the meeting to a close.
I'm Farah Papaioannou. I'm Todd's wife and also one of the co-founders of EdgeWorks. I was just giving Todd the access to my laptop because he couldn't hear off of his phone, but I ended up listening in on the meeting. It was really actually quite interesting. So thank you for letting me participate. Really great discussion, you guys.
Farah also has not mentioned this, she's being modest, but she is on the board of the Eclipse Foundation. So helping drive all this stuff and just drive open source in general.
Thank you, Kilton, yeah.
I'm Kate. I'm one of the maintainers for Acry, and it was great to be here and talk about it a little today.
I had a question for Akri, UK, and also Jiri. I noticed that the repo is under Deis, or was it Deis? I don't know, instead of Microsoft. And I think that acquisition happened, like, wasn't it years ago? Does this date back that long to being a Deis project, or is Microsoft simply using that GitHub repo, for convenience in this space?
From what I remember, I think Microsoft acquired Deis in 2016, and it's kind of where Azure puts our cloud native projects. And so Acry is only like a year and a half old. So we're a recent addition to Deis Labs. But yeah, that's where you can find Helm and Crestlet and all of those other projects as well.
No, yeah.
I think at some point, actually, so go ahead.
I just wanted to add to that our intent was not to have this as a Microsoft governed project, and so this was also kind of to go say, yep, we want this to be community driven, just like Helm and other Deis Labs projects. That's why it was kind of put into the repository of Deis Lab.
Okay, thanks.
Yeah, no, sorry, apologies for interrupting. I think I was going to say at some point it'd be great to chat with you guys, at least from the ioFog standpoint, in our next release, which is scheduled for kind of end of Feb. We have this notion of edge resources, which is our way of basically, discovering and binding real physical resources and kind of like, surfacing them up through the ioFog agent at the edge and then making that available to the, the ioFog cluster or beyond for scheduling or access. And so it seems reasonable that we should have, a conversation to see kind of, how we, could maybe use or implement or, collaborate with the Acry folks. I think there's definitely a lot of very, very similar ideas there.
There's also an interesting tie-in I'm aware of in another Kubernetes user group. I think in the things I read about in the repo, it talked about discovering GPUs and FPGAs. And this is more a data center application rather than edge, but there are projects out there that attempt to share pools of GPUs for machine learning applications that really aren't edge-centric, but still use network connectivity to the GPUs. And it looks really interesting. So I'll be looking into that.
Cool. We would definitely not be probably sharing those privileged resources at the edge, but the discovery of them, we'd like to do it the same way as others are doing it. There's no need to replicate that or have it work one way in the cloud and a different way at the edge. Yeah, so the pooling, probably not, but the discovery, yes, that's cool.
Yeah, and specifically on top of what Kilden's saying, I think, Steve, what we're seeing is just the explosion of kind of GPUs, VPUs, TPUs, like at the edge, as embedded little, solderable chips or, plug-in USB devices or M2 form factors that, the majority of the workload that we see really driving, I think, value at the edge for a lot of people now from wallet share standpoint is kind of AI inferencing running on these small form factor devices. And so that's actually kind of has been a core focus for us over the last couple of years, is making all of those things available to the developer in the kind of microservice Docker layer, right? So it's seamlessly making it available.
Yeah, the use case at the edge might be something like having a handful of GPUs specifically for image recognition and maybe 100 cameras that are handled by 10 GPUs for doing face recognition or license plate recognition. And I think there are applications that could be really enabled by that.
Yeah, definitely. Or 100 cameras with 100, dime size, inference engine TPUs like a Google Coral, just actually running on the camera. That's actually, a compute board where you're running the actual inferencing right there, kind of like on that smart camera doing the real-time video stream processing. That's what we're starting to see. We have a very predominant use case out there.
Okay, any other newcomers, or do the newcomers want introductions from the ones who've been here consistently? We can do that too. Otherwise, I'm going to call the meeting to a close and let people go on with their normal day job.
Yeah, I would certainly mind getting to know the people on the call.
Okay, I'll start. I guess I'm Steve Wong. I'm one of the co-leads of this IoT Edge working group. I'm based in Los Angeles working for VMware. I am assigned to work on the Kubernetes project, and I've got a couple roles. I joined this group not because of my current role at VMware, but prior job at another startup. I was one of the founding engineers of this company, Wonderware, that did a toolkit for factory automation, and worked there over a decade. So I've just always been interested in the space. And when I got on board Kubernetes, I realized that, or I'm convinced that Kubernetes enables features that would be really useful in that industrial IoT space, to the point where I think if you were to redo what Wonderware did, and they really in a way took over the world with that at one time, they got penetration into 85% of the world's factories. So it was pretty dominant. But I think Kubernetes, along with projects like what we've been talking about today, have a real disruptive potential to do it in a much better way than those solutions that came out of the 90s were. Now, the space moves so slowly that you've still got things like the, the Discovery brought up OPC UA, and that OPC standardization came out in the 90s as a way to unify the different device interfaces. So some of the legacy stuff is still alive. Some of it won't go away for another 20 years and needs things like these gateways to continue to link up to it, but it's an interesting opportunity. So let's go and just have whoever introduces themselves choose the next person. So Dejan, do you want to go?
Yeah, hey, I'm an engineer with Red Hat. Been coming from the enterprise messaging land, and then dive into the IoT and all this edge stuff. Also one of the co-founders of this group, and yeah, being messing around, mostly interesting in the connectivity and messaging around these use cases. Barry, want to go next? You're muted.
I unmute Barry.
Sorry about that. Barry Kaplan. I work for a company called Vimana. We're more a user of all these kind of technologies. We focus on industrial IoT type applications. We started mainly in factories. We're the ones that have to deal with all these 30-year-old crap and systems and figure out how to bring them into the modern world. So figuring out how to layer these protocols on top of all the old hardware has been one of the things we've been working on for quite a while. Now we're moving into other IoT domains as well. So all these technologies apply to us. Oh, next. So who else wasn't here? I guess. Well, I guess I haven't seen Todd before, even though you're with Edgeworks. So I'll let you go next.
Thanks, Barry. Todd Papaioannou. I'm actually the CEO over at Edgeworks. Been a long time open source developer, built Greenplum DB back in the day when I was at Greenplum. Went to Yahoo, built Hadoop there, started a company called Hortonworks, and I've been contributed to Apache, to Eclipse for close to 20 years now. I will, well, no Serge, obviously. Jiri?
Hey folks, so my name is Jiri Appl, coming from Czech Republic, hence the weird name. And I've been at Microsoft for about 10 years now, most recently looking at Kubernetes and on the edge. So Microsoft has plenty of Kubernetes offerings, but we think that Kubernetes is really interesting for the edge. And so we have multiple kind of thinking in that area, Acry being one of them. And, be happy to kind of keep in touch with all of you and kind of keep working on this together. We think that with Acry, we can kind of go further where we are right now, but we want to have that community engagement. And I think Kilton, yeah, I don't think you introduced yet.
Oh, right, thanks. Hi, Kilton Hopkins. I'm the chair of the Eclipse Edge Native Working Group and co-founder of that group, co-founder of EdgeWorks and currently CTO of EdgeWorks, and also the original creator of the Eclipse ioFog project, which came out of years of looking at these types of problems, like the way Barry describes, like having to be the one to make this crap work, and then saying like, you know what, I'm not seeing anything alike. And that originated back in 2014 when I was an IoT advisor to the city of San Francisco, and they said, what would you recommend? And I said, nothing. Like we got to get started fixing this. So yep, so that's who I am in my history. And let's see. So we've had everybody so far except Serge, and even though you introduced yourself a little bit when you started talking, could you give us a little bit more well-rounded? And I think that sums it up.
Yep. So I'm Serge Radinovich, work at EdgeWorks. I do focus on our Kubernetes work. So working on the port manager, operator, anything that comes out of that. Done a bunch of work on the CLI, ioFog control, and just all the associated tooling and automation with that kind of stuff. Always been interested in Kubernetes since I learned about it, and just realized how much it enables in distributed platform sort of situations.
Okay, by any chance, did we leave anybody out? If so, speak up now. Okay, I'll take silence as no, and we've gone over, but it's been fascinating, so it's okay if we went over. Thanks, everybody. The recording will be posted soon, maybe not tomorrow, but I aspire to it sometime within the next week, and we'll see you at the next meeting. Thanks for joining.
Cheers.
Thanks, everybody.
Bye.
Bye, folks.
Bye, everyone.